Assalamu alaikum. This presentation is on several plastic surgery techniques for the repair and primary closure of surgical defects, particularly in exposed areas like the face. While considering the options for closing up a surgical defect like this, particularly in an exposed area like the face, the primary aims are to have a minimal amount of tension in the wound and to avoid having trapdoor or dog ear deformities and to have a neat scar at the end that lies parallel to relaxed skin tension lines. And traditionally having an elliptical or a fusiform shaped defect or transforming a circular or a square defect into an elliptical or a fusiform shape helped with all these aims. The elliptic form defect would have a 30 degrees angle at the apex and have a length to breadth of 3:1. The other simple thing that can be done to avoid a dog ear is to apply the rule of halves while putting your sutures in the wound. This entails trying to figure out where is the midpoint of the two sides to join them together, and then going from there to the midpoints of this segment and the midpoint of the other segment, and between any 2 points find the midpoint here and the midpoint there to join by suturing. One thing that you can add to this is start by doing a suture at the two ends first before starting suturing in the middle. If you have a suture at one end here and one end on the other side, then you would avoid having the dog ears at the edges. That's the commonest site where you get the dog ears. And then you start in the middle after this, and then go back and have another suture here and another suture on the other side, and keep doing this, keeping putting your stitches midway between any two stitches so as to bring about even distribution of the sutures and the tension along the entire length of the wound, but you have secured the angles by placing first lateral sutures. The drawback of changing a circular lesion into a fusiform defect is that you lose extra living normal tissues at both ends of the circular defect. And one way around it is to use the M-plasty technique. This is a tissue sparing technique. It aims to spare a part of the tissues that would have been discarded if you have a fusiform configuration for your defect, while still avoiding having dog ears at the two ends and avoiding having extra tension in the middle. So you place an M incision centered on the edge of the safety margin, going out to the edge of the fusiform and going back in here. So you have now an M-plasty on one side and another M-plasty on the other side. And this will spare this rhomboid shape in both ends of the circular defect, and the wound would heal nicely in almost straight line with two smaller extensions on both sides, no dog ears and minimal tension, but you have to be very careful in suturing these 3-point junctions. Much like the conventional way of having an elliptical excision of a lesion together with a safety margin rather than a circular excision to prevent the formation of the dog ears, this S-plasty provides the same advantage, but rather than having a triangle at the ends, you have now a crescent. This is obviously longer, so you can provide the 3:1 ratio or 4:1 ratio in a smaller space, and you also have a more acute angle at the end to avoid having any dog ears. It's particularly useful when you want to prevent any tension on the central part of the wound to avoid wound depressing. That's useful when you are working over convex surfaces like the nasal bridge or the chin. That's the main advantage of the S-plasty, plus it can be combined with an M-plasty to preserve further tissue. When the wound geometry of elliptical conventional excision and the S-plasty were compared, it was clear that in comparison to the conventional way, the S-plasty provides less central depression of the wound and less elevation of the wound edges compared to the other technique. This is basically because the tension on the wound while healing on the two crescents will be in opposite directions. So this would help in flattening of the wound in a better way and preventing the depression of the central part. So this is a good way of redistribution of the tension. The other big advantage of the S-plasty is when you are excising a dumbbell lesion like this, rather than transforming this dumbbell lesion into a big crescent around it, you can actually remove it with a safety margin. And now you suture one of the central points, A into here and B into the other side, and you end up with an S-plasty that have preserved more tissue and distributed the tension in a better way. So this is an example of where the S-plasty technique would be useful in facial surgery. In an uneven surface like this beside the malar bone and the nasal bridge, if you want to avoid having these convex areas, you can place the S-plasty somewhere in there, and by having the configuration of the S, you redistributed the tension so that the end scar tissue is not going to tent and fold over the surface, giving a very ugly deformity. And it is actually how meticulous you are going to stitch this wound, particularly if you combine it with an M-plasty, how meticulous you are in placing the three-point junction and putting the sutures in the skin with a 5/0 or a 6/0 nylon at the end. You end up with a fairly good scar. This is the S-plasty technique combined with the M-plasty. The S-plasty is drawn first within the same distance like the traditional fusiform, but have more length and more acute angles. And now the M-plasties are added, so spared some tissues, have more acute angles here, less of a chance to have dog ears, less tension in the central part as well. Another tissue preserving technique in addition to the M-plasty or the S-plasty is the Double S-plasty technique. In the traditional elliptical or fusiform wound configuration, the central circular part here contains the lesion and its safety margin. The two triangular pieces at the ends of normal tissue have actually a surface area of more than 150% of the circular part. This waste can be halved if you run an imaginary line bisecting the wound from one apex to the other, and you can only take half on one side and half on the opposite side, preserving some more tissues on both sides. In the double S-plasty technique, the central segment containing the lesion and the safety margins are marked together with the usual configuration of the fusiform shape are marked, but only half the extensions are taken with the lesion, one half on this side and another half on the other side. And then you place the sutures obliquely across the central segment from the angle to the midpoint of the central segment here, and from the other angle to the opposite midpoint of the central segment here. You'll have the sutures passing here obliquely, diagonally. And this will put extra tension on the central compartment, but the advantage is we have saved half the amount of the tissues that could have been discarded with a circular, triangular, or square defect in an area where there is abundant adjacent elastic tissues. One can have no difficulty in designing a flap that's going to fill up this defect, either an advancement flap or a rotation flap. The flap would close with no much difficulty, and the final closure would be with two limbs, giving a shape of an L, and is sometimes termed an O to an L reconstruction or an L-plasty. There would be situations, however, when it is crucial that no tension at all would be applied to one side of the defect. The side of the defect that lies close to an important anatomical landmark, and it is important to have this line not distorted, the horizontal bar of the T, if you can see it. In that situation, you would consider having the O to T or an A to T type of reconstruction. When you use tissues from both sides of the defect, advance them or rotate them over the minimally distorted bar of the T, and have two small porous triangles on either side of the horizontal bar of the T, and that would give you the A to T or the O to T type of reconstruction. The A to T plasty is best applied to a triangular defect or a defect that can be made into a triangle. Like if you have a circular lesion or a circular defect, you can draw a triangle around it with its height twice the diameter of the defect. If this diameter is a D, this should be 2 Ds, and the base of the triangle would be 1 D. The angles at the base are equal, and each is about 75 degrees, so that you would have an angle at the apex of 30 degrees that can be closed primarily with no much tension. To avoid the formation of dog ears, you need two porous triangles on the other side of the horizontal bar of the T. The base of this equilateral triangle is half a D. So again, half the diameter of the defect will form the base of two equilateral triangles here. And when this triangular defect is created, these two flaps from either side of the defect would meet in the midline here with minimal distortion to the important horizontal bar of the T. So this is to demonstrate the simple technique. You have transformed the circular defect into a triangular design, and you have the two small porous triangles at the two ends of the horizontal line. And once these porous triangles are removed, it will be easier to mobilize the flaps from either side of the defect to meet in the midline in a vertical line perpendicular to the horizontal line that you want to preserve. So that's the lesion removed, and you have now this triangular defect left. And now the two advancement or rotation flaps can easily be mobilized from the two sides to meet in the midline. And what you need now is to close these two porous triangles. And as you can see, there is minimal distortion to the horizontal bar of the T. With the well-designed dimensions and angles of the triangular defect, there should be no much tension in closing the vertical and most of the horizontal bars of the T. And this vertical shaft can be closed either by interrupted sutures or subcuticular suture, and the same applies for most of the horizontal part. There would be 3 points that requires extra attention and care. The point in the middle where there are 3 flaps meeting, and you need to have a subcuticular 3-point junction suture and the 2 points at the ends of the horizontal bar where you have an angle stitch. The horizontal bar of the T does not have to be always a straight line. It can be convex upwards like in the first example or concave like in the second. In the first example, this is a triangular defect just adjacent to the upper lip, and the flaps will be created by extending the horizontal line of the T along the upper lip margin, and by this you've created two flaps on either side of the defect that can be mobilized to meet in the midline with minimal distortion to the line of the lip. That's the whole idea, to keep this horizontal bar of the T as minimally distorted as possible. And the other example, you would have a supratip lesion and a supratip defect, and now you have this concave line for the horizontal bar of the T and two flaps from either side of the defect that can be brought to meet in the midline, so you have a T-plasty with a horizontal bar that is a bit curved. And now we move to the Z-plasty technique. If we have a defect, a wound, or a scar, or a web going in an unfavorable direction or with unfavorable dimensions, like if it's too short, for example, this can be corrected using the Z-plasty. The fundamental units here will be two triangular flaps, one on each side of the scar or the defect, that will be transposed. This triangular flap will go down and this triangular flap will go the other direction up there. And this will have four effects on the defect, depending on the angle at the apex of the triangles. If the angle is 60, for example, then the direction of the scar or the web will be changed 90 degrees. The new direction will be perpendicular to the original direction. There's also a lengthening effect on this segment. It would increase by 75% if the angle here is 60 degrees. And there will be a corresponding decrease in the perpendicular dimension. So this dimension will also contract a little bit. And the shape of the wound will be no longer a linear defect or a linear scar. It will take the form of the Z. And depending on the angle at the apex of the triangles, the configuration of the wound would change. If the angle is too acute, like if it is, for example, a 30 degrees angle, then the increase in the length will be 25% rather than 75%. If the angle is 45 degrees, we will have a 50% increase. If the angle is more than 60, like if it is 75 degrees, for example, you get a 100% increase in the length of this segment. But as the angle increases above 60 degrees, a transpositioning of the flaps becomes a little bit more difficult. Here is a wound or a scar running in an unfavorable position, and we want to correct it by a Z-plasty. We first measure the length of the central limb and then extend two equal lateral limbs with a thread and mark the angles of the lateral limbs, and that should be, say, 60 degrees. We divide the 90 degrees in three equal parts and then have 60 degrees equal lengths. And if the measurements were right, you check this. It's not too bad. But also, if you extend a line from the apices of the two lateral limbs, they should join in a line perpendicular to the central limb. Now the flaps are created and transposition, and now you have a better alignment of the central limb
parallel to the nasolabial fold.
So there will be situations like this one when you have a contracted scar quite close to the eye and affecting the eyelids. And if you want to place one of the limbs of the Z-plasty in a relaxed skin tension line, it may not be possible to place the other limb in another relaxed skin tension line in this situation. And because of this, some variations to the standard Z-plasty technique may have to be considered, provided that you still have an angle that is not less than 30 degrees, so as not to jeopardize the viability of the tip of the smaller flap, then unequal angles may be considered. There would be situations in which there would be concerns about the viability of the skin flaps of the Z-plasty, particularly the tip of the flaps where you expect a significant reduction in the blood supply. In situations where the skin is previously irradiated or has a burn in it, you may increase the perfusion to the tip of the created flaps by increasing the angle using curvilinear lines rather than straight lines in the created flap. It's important, however, in such situations where there are concerns about the blood supply of the skin, is to consider carefully the pros and the cons of doing the Z-plasty in the first instance.
In some situations, we may have to consider doing multiple Z-plasties rather than just a single big Z-plasty. In situations where there's a lack of tissue availability or tissue laxity above and below the central limb, then you may consider doing the multiple Z-plasties in series. Or if you want to extend the central limb a bit more than what you could have achieved with a single Z-plasty, you consider the other version, the multiple Z-plasties in parallel. In the in-series type, the central limb is divided into smaller units, smaller Z-plasties, and by this you only recruit a little amount of tissues above and below the central limb, but achieve an equal extension in length of the central limb. Either you have the Z-plasties going in the same direction or in opposing direction. In the other version, the in-parallel type, the central limb remains the same, but now you have, based on that central limb, two sets of the Z-plasties, one with the 90 degrees and the other with the 45 degrees. You actually have four flaps here that are going to be transposed, and this will give maximum extension of the central limb. You can do a 4-flap or a 6-flap if that is required, and you can vary the angle at the apex as well.
How much you can increase the length of the central limb with multiple Z-plasties? If we start with the in-series type, and this is a 4 centimeter segment, if you do one single Z-plasty with 4 centimeters central limb and 4 centimeters lateral limbs, you gain a length of 75% increase to this 4 centimeters, like another extra 3 centimeters, because we've used the 60 degrees type. Now, if you divide the central segment into 4 smaller units, each 1 centimeter in diameter, you end up having the same extra 3 centimeters, because 4 multiplied by 4 smaller 1 centimeters Z-plasties multiplied by the 75% would also give you the same amount of extension. And the same applies if you have a 2 centimeters here and a 2 centimeters there for the opposing version of the multiple Z-plasties in series. Now, if you're doing the in parallel type, if you actually need more extension of the central limb up to 100% or 150% of its original length, then the in parallel type of multiple Z-plasties will be required, either with 45 degrees 4 flaps, then you can expect 100% increase, or 45 degrees
6 flaps when you can have 150% increase in the length of the central limb. This is the in series type of multiple Z-plasty. We're starting with a 4 centimeter scar or wound or web, and rather than doing one single large Z-plasty 4 centimeters lateral and central limb, we are doing 4 smaller Z-plasties, each with 1 centimeter in length. The angles remain 60 degrees each. Now we are using much less tissues above and below the central limb than we could have used if we are doing a single large Z-plasty. The double opposing Z-plasty, you start again with the 4 centimeter segment divided into 2 opposing Z-plasties, each with 2 centimeters. This will give you this time 5 flaps because there will be an extra flap in between the 2 opposing Z-plasties. You undermine and mobilize the flaps, and then you take the central flap number 5 in here and interpose it between 1 and 2. This will form the first flap to be secured in position, and then you transpose the 2 other flaps laterally. Number 3 would be lateral to 1 and 4 would be lateral to 2. And once you have them in position, you have extended the central limb by about 75%. Increase in length, that's an extra 3 centimeters for a 4 centimeters scar or wound. This is the basis of the Furlow operation that we use in the cleft palate repair. If more extension of the central limb is required, then we consider doing the multiple Z-plasties in parallel. Now we have this 4 centimeters in here, and we draw 90 degrees above and below. If we are choosing the 45 degrees version, divide these 90 degrees into 245 degrees above and below. So you have now 4 different smaller flaps for the multiple Z-plasty. Number 2 and number 3 are in the middle, and this should go to the most lateral parts. You transpose each pair and have number 2 and number 3 most laterally, and when you secure them in position and check the extension and the length, you see that you could have gained almost 100% increase in length by the in parallel version. In the surgery of flaps, the development of dog ears is sometimes inevitable. Generally, dog ears are of 2 types: the full cone, like in this, where you have excess skin on both sides of the wound edge. It's usually due to rotation of flaps or transposing flaps, or due to a wide angle at the apex, more than 40 degrees or so. The other type, the half cone, is due to discrepancy in the length of the 2 lips of the wound. Like if one wound edge is much longer than the other, then there will be a redundant part of the skin forming a half cone. These types should be differentiated from pseudo-dog ears, in which there isn't actually excess skin, it's just the puckering is due to the subcutaneous excess fat, and it can be sorted out by removing the subcutaneous fat or partially and without excision of any skin. If the dog ear is small, say less than 8 millimeters, then it may be worth treating it conservatively, because most of these small cone dog ears would settle with time within a few weeks or so. But if it is larger than 8 millimeters but still less than 15 millimeters, something may have to be done, and that may be just excision of excess subcutaneous tissue, fat and subcutaneous tissue, and perhaps opening up few sutures and trying to resuture them with the rule of halves, and that may distribute the excess skin at the corner along the wound edge and the dog ear may then resolve. But if the dog ear height is more than 15 millimeters, then the excess skin has to be removed. In the case of the half cone, like in this example, it will be removed from one side. In the case of the full cone, it will be an elliptical excision from the two sides. Here is how a half cone dog ear is formed. You have a wound here with asymmetrical edges. One edge is much longer than the other. When they are folded together as if they are stitched, you will see that the half cone is forming at the angle here. The best way to sort this out is to extend the shorter segment with an angle of about 40 to 50 degrees. So that will be a hockey stick extension. This will be incised to release a triangular flap of the excess skin on the longer side. This can be folded on the wound edge so that you could mark out how much exactly you would need to excise. And once this is excised, you will see that the wound configuration is now fusiform, and this was the extra bit of skin in the corner. But if the dog ear is of the full cone type with excess tissues on both edges of the wound, then an elliptical skin excision from both sides will be required. When we try to suture this circular defect, you'll see dog ears forming full cone on both sides, and this elliptical bit of skin would have to be removed to flatten the wound so that you would have a straight wound edge.
By this, we come to the end of this presentation on some plastic surgery techniques for primary repair of a defect in an exposed area like the face. Assalamu alaikum.